In this lesson, I'll show you how to solve second-order differential equations by the Laplace transform. This is question number 1 in the series. The question reads, solve the second-order differential equation y double prime plus 4 times y minus 3 is equal to 0, where y is a function of t and y prime are both 0 at t is equal to 0. So let's write that down. Y prime at 0 is equal to 0, and y at 0 is equal to 0. To do this question, I'll be following these 4 steps, and I've given this question a difficulty rating of medium relative to what you'll see in question number 2, where we have to combine algebraic manipulation in order to actually come up with the answer. The first thing that I will do, according to these steps, is to take the transform of each side of the equation. So let's go ahead and do that. We have the Laplace transform of y double prime plus 4 times the Laplace transform of y. Notice that I removed this 4, which is supposed to be in here outside, minus the Laplace transform of 3. This is equal to the transform of 0. For this one, I will be using the following relationship where the Laplace transform of f double prime of t is equal to the right side. So I can use that for this term where I have s squared times the transform of y minus s times f at 0, which we were told is equal to 0. So s times 0 minus f prime at 0. So our y prime at 0 is also 0. That takes care of many things. These two go away. Next we have plus 4 times the transform of y. I'll leave that the way it is because in step number 2 they want us to solve for the Laplace transform of y. So I have plus 4 times the transform of y minus the transform of a constant 3. And according to our chart, if you have f of t is equal to a constant, in our case it's 3, the answer is 1 over s times the constant. So for this we'll write down minus 3 over s. It's like saying 3 times 1 over s. And this is equal to the Laplace transform of 0, which is 0. Let's clean this up. We're almost done. We have s squared times the transform of y, those two went away, plus 4 times the transform of y. And I'll bring this term over to the other side because remember in step number 2 we want to solve for the transform of y. So I have 3 over s. Now I will factor out the transform of y from these two terms, giving us s squared plus 4. This number right here is equal to 3 over s. One last step to isolate for the Laplace transform of y. I divide both sides by s squared plus 4, and this gives me the transform of y is equal to 3 over s times s squared plus 4. Step number 2 is accomplished. Moving on to step 3, they say manipulate f at s until it matches one or more of the table entries. Now for reference, I already know that this will match transform 21 in this table, and it looks like this. And if I take the inverse of this, I end up with 1 minus cosine a times t. One of the problems that we have though is this can be matched with a is equal to 2, but we're supposed to have a squared up here, so this is supposed to be 4. To compensate for the fact that we have a 3 where it should be a 4, I'm going to multiply this function by 3 over 4. By doing that, what's supposed to be a 4 here will cancel out, and you're left with that 3. And we're going to use 3 over 4 as the coefficient of 1 minus cosine at. Here's what I mean. The Laplace transform of y is equal to 3 over 4 bracket 1 minus cosine 2 times t. And there you have it. All 4 steps are accomplished, and that is how to solve second-order differential equations by the Laplace transform. If you are looking for a more challenging example, make sure to watch question 2 in our next video.